Find f of x given that f of x equals limit as x approaches to 0 of x squared sine of 1 over x. Okay. Okay. So the issue here is this x squared over x squared. As x approaches 0, this will approach 0. Or 0 squared if you prefer, but 0 is probably good enough. And then this other one right here, sine, this becomes basically sine of infinity, which is kind of meaningless. We know what sine of 0 is. Sine of 0 is 0. So sine looks something kind of like this, where it goes between 1 and -1. And this goes all the way out to infinity. And so when we have sine of infinity, it doesn't really approach anything. So there's not really a limit as sine approaches infinity because it keeps going up and down. So if you have the limit as x approaches 0 of sine of 1 over x, basically sine of infinity, and you wouldn't really know what it would be. You know it'd be between +1 and -1, but you don't know where it would be on that scale. Or along that spectrum, that interval. Interval, that's a good word. And so you really don't know what to do with it. Luckily, so the sine of 1 over x as limit as x approaches 0 does not exist. The limit does not exist because it's somewhere between -1 and 1, and you can't pin down a number. But we know that x squared, which looks like this, does approach 0. So when we multiply that by sine of 1 over x, which we know that sine of 1 over x is going to be somewhere between 0 and -1 and 1, we can look at it and kind of be like, okay, so here is, eesh, that looks terrible. Okay, we can do better. I believe in us. Graph, alternate color, purple. X squared. Nope, I wanted purple. I wanted purple. X squared. This is just for x greater than 0. And negative x squared. The reason I do negative x squared is because if sine of 1 over x is negative, then it's basically going to be -1 times x squared. And so this sine of 1 over x is going to be bounded by x squared and negative x squared. So if we draw our sine, it'll look probably something like this. And your first thought was, what? You just said that sine of 1 over x is going to be between 1 and -1. Well, it is, but we're multiplying it by x squared. So if this is like, I don't know, 3x squared is 9. So then sine of 1 over x will be bounded by +9 and -9. And then this goes on towards infinity. Long story short, what we can do then is we can just look at this x squared value here, and that's going to determine what the total function is going to go towards. So the limit as x approaches 0 of x squared sine of 1 over x is going to be, term is bounded. It's going to be constricted, restrained by, what's another word? Fettered? No, there's got to be, there are many other words about shackled or some such. That's okay. Bounded is probably good enough. The limits are going to be based on x squared. And so as x squared goes to 0, sine of 1 over x is also going to have to go towards 0. And so even though the sine of 1 over x, that limit doesn't exist, we know that the limit as a function as a whole will exist, and that will be 0. So that's how you approach this problem. This, if you want to look it up, it's referred to often as the Squeeze Theorem. And the idea is that sine of 1 over x is squeezed in between x squared. And so this is the idea of how you use the Squeeze Theorem. Someone would be like, well, it's, just logic. You look at it, it makes sense. And that's true. Most math is. But the official, if you want to look at something and you want to Google something or whatever, duck, duck, goose it, Squeeze Theorem is what you probably want to look up. So that's how you approach this problem. Thank you much. See you on the next one.